As promised, and you all know I'm always a man of my word, here's the next application of differentiation using a chain rule. This is a question where we're supposed to determine the points, if there are any, for which the graph of the fifth root of x cubed minus 12x has horizontal tangent lines. So by now you know this is an easy translation. Horizontal tangent lines is where the slope are zero or where the derivative equals zero. So you need to find out where this derivative, y prime, equals zero. So the derivative is the chain rule, would be 1/5 x cubed minus 12x to the negative 4/5 times the derivative of the inside, which is 3x squared minus 12. Now, unlike the tangent line problem, I am going to simplify this because I'm not plugging in anything for x. I'm trying to solve for x. So it's a pretty simple simplification. I have a 3x minus 12 up top, 3x squared minus 12 up top, and the 5 times x cubed minus 12x to the 4/5 on the bottom. So that looks complicated, but it's not because we're trying to figure out what this equals zero. The complicated part is on the bottom. But a fraction, which we have, only equals zero when the top equals zero, so we have that going for us. We can just write down 3x squared minus 12 equals zero. Find out where that equals zero. I'm going to do it by factoring. You can do it by just bringing everything to the other side. The factors that make this zero are x equals negative 2 and x equals 2. The 3 doesn't equal 0, so you never had to worry about it. So those are the x coordinates of the points at which this graph has horizontal tangent lines. We need the points, which require an x and y coordinate. And we're looking for the points on this graph. So you have to plug those x values back into this graph. So for x equals negative 2, and I'm going to do that up here just for I have room. So y would equal the square root, or the fifth root, of negative 2 cubed, which is negative 8, minus negative 12 times a negative 2, which is 24. This would give us the fifth root of 16. Now, 16 is not a perfect fifth root. There's no number multiplied, there's no integer multiply itself 5 times that gets you 16. So that's it. That's the y coordinate. For x equals positive 2, do the same thing. Y would be the fifth root of, you have 2 cubed, which is 8, from here, minus 12 times 2, which is 24. That would give us the fifth root of a negative 16, which, remember, is perfectly fine. You can have negatives inside an odd root. So the final points would be negative 2, comma, fifth root of 16, and 2, comma, the fifth root of 16. Now, you can check this on your calculator, and I am going to do that. I don't want to fumble around with my calculator right now, though. So I'm going to pause this and make a new video, a new bonus video, lucky you, to show you how to check this on the calculator. So that will follow this. Obviously, it will probably be a short video, but you know me, I'll probably talk all over it. So I'll see you then.